Okay, so question 15. First of all, we need to fill out all of our earliest starting times, and then we need to work backwards and fill out all of our latest starting times. And you can see straight away from the question that they've given you space to do that. So that's a pretty good place to start. Okay, so we're starting with 0. We always start with 0, and we fill out the left-hand side first, which is the earliest starting time. Okay, now we go on. If we want to go up here to this next one, there's only one pathway that leads there, so it's just going to be 0 plus 2. It has to be. There's no other pathways. This one here, again, there's only one pathway leading here, so it's 0 plus 1. And again, only one pathway that leads here, so 0 plus 5. All right, next one here, there's only one pathway again, so it has to be 5 plus 2. So that's nice and easy. This one up here, there's 3 different edges leading to it. So there's 3 different pathways. So we'll leave that for now until we know all 3, because at the moment we only know these 2. We need this one first. So up here, how many pathways lead to this one? Only this one here. So that's nice and easy. 2 plus 3, 5. All right, now we've got all 3 pathways that lead to this one. So we can choose which pathway we're going to choose. Well, when we're doing the earliest starting time and we're moving from the start to the finish, we always select the pathway that takes the longest amount of time, okay? So we have to factor that pathway in. So in this case, we've got 5 plus 2, which will give us 7. Here we've got 1 plus 4, which gives us 5. So far 7 is the longest pathway. And down here we've got 7 plus 1, which is 8. So this is actually the greatest value. So this is the one that we're going to put in, 8. Now we're moving on to our next one. Okay, so how many pathways lead here? We've got this one and this one. So we've got 2 possible edges leading towards this vertice. So this option up here is 5 plus 6, which gives us 11. And this option here is 8 plus 7. Which gives us 15. So 15 is the greater value. So 15 is the one that we'll use. And then there's only one edge here that leads to the last point. So it's 15 plus 2, it has to be. Okay, so now we've got our earliest starting time. And our latest starting time is also going to be 17 now. And we're going to work backwards to fill in the right-hand side of the boxes. Okay, so there's only one arrow that leads back here, so it has to be 17 minus 2, so it's 15. Now, if we were to do this one, well, there's actually 2 arrows that lead back here. If we follow these backwards arrows, we follow these arrows backwards, there's 2 that leads here. So we need to know this one first before we can choose which edge we're going to follow the pathway along. So we will leave that one for now because we don't have this. Can we fill in this one? How many edges lead back here? Only one, okay? Because these edges are going forward. We need the one that goes back along the arrow backwards. So this one is 15 minus 7. So that leaves us with 8. So you can see that this is the critical path so far because these are the same, these are the same, these are the same. So critical path is going to come along here. Okay, now we can do this one because we've got 2 options. We can do 15 minus 6, which gives us 9, or we can do 8 minus 2, which gives us 6. And now when we're working backwards, we don't take the largest value anymore. We have to take the smallest value, okay, the shortest time. So 8 minus 2 is the shortest, so it has to be 6 up here. We can go here and do this one because there's only one path leading back, so it's just 6 minus 3. What else can we do? We can't do this one yet because there's all these different pathways leading back, so we need to know these. We can do this one because there's only one path that leads backwards here. So it's 8 minus 4 is 4. We can do this one because there's only one path that leads back here. So it's 8 minus 1 is 7. So you can see this is the critical path because the earliest starting time and the latest starting time are the same. So that leaves it with no time to spare. And then this one again, there's only one path leading back here. So it's 7 minus 2. So we're still on the critical path, but we have to be. We've got no choice. There's nowhere else to go. And then we can decide this one. We've got 3 different options and we have to choose the smallest value. So 3 minus 2 is 1. 4 minus 1 is 3, so it's not that. 5 minus 5 is 0, so that's the smallest value clearly. So the critical pathway is from here to here, up here, and then out like that. So that's the critical pathway. Now, what's the question actually asking us? So it says if activity G is delayed by 5 hours. So where's activity G? So activity G is up here. It's got an earliest starting time of 5 hours and it's got a latest starting time of 6 hours. So that means that this activity can start at 5 hours, but it can also be delayed by 1 hour and start at 6 hours. So that means it's got a float time of 6 minus 5, or 1 hour. It's got a float time of 1 hour. So that means that we can actually delay this activity by 1 hour and it's not going to affect the total time for this process to be completed. So the question asks us to delay it by 5 hours. So for the first hour, it's not going to affect it. But for the remaining 4 hours, that's going to delay the whole thing by 4 hours, okay? So the question says we're going to delay it by 5. How much is that going to delay the whole thing by? How much is that going to delay K by over here? Sorry, it says how much will K be delayed by, and K is right at the end over here. How much will it delay the critical path by? Well, it doesn't matter about that first hour because we've got a float time of 1 hour. But the remaining 4 hours, it will delay this critical path by 4 hours. So your answer is basically going to be the amount they asked you to delay it by minus the float time, which is 1, okay? So it delays the process by 4 hours. So it delays K by 4 hours.